Stanisław Barszczak. The universe is infinite. I will not say game over. Dear internet users, there is no doubt about the black holes are at the limit of what we can know. A black hole is an area of space-time that, due to the influence of gravity, nothing, including light and information, can leave. According to the general theory of relativity, for its formation it is necessary to accumulate a sufficiently large mass in a sufficiently small volume. The black hole is surrounded by a mathematically defined surface called the event horizon, which marks the boundary of no return. It is called black because it completely absorbs the light that hits the horizon, reflecting nothing, just like a black body in thermodynamics. Quantum field theory predicts that black holes emit radiation like a black body with a non-zero temperature. This temperature is inversely proportional to the mass of the black hole, making it very difficult to observe in black holes with stellar mass or greater. But recently scientists have just discovered the first ever white hole. The cosmic world has layers of mysteries that amaze us, and thanks to the endless efforts of scientists and the methods, these layers are exposed, leading to surprising discoveries. Now something truly amazing has come into the hand of scientists. We are talking about the first white hole in history. You've heard of black holes, but what is it now? A white hole is a theoretical area of space-time and singularity. This is the polar opposite of a black hole, one that can only be accessed from the outside and from which no energy, matter, light, or information can escape. In the theory of eternal black holes, white holes appear. In the solution of the Einstein field equation, there is an additional white hole zone to the black hole region. This area does not exist for black holes that have formed as a result of the gravitational collapse. Nor are there any known physical mechanisms that can lead to a white hole. At this point, I will recall the Doppler phenomenon, a physical phenomenon for waves consisting in the difference in the frequency of the wave sent by its source and frequency of the wave recorded by the observer who moves in relation to this source. Here is an advanced scientific note on Doppler. If light travels away from you at a constant speed in a static flat, Minkowski theory, space-time, no matter how red it is, you will never conclude that it is traveling faster than light. Note here the conclusions that can be drawn if you mistakenly use the Doppler in the context of a curved space-time in the universe, where expansion occurs. Interpreting the massive Doppler redshift could suggest that the galaxies we see are moving away at speeds close to the speed of light. And since what we are actually seeing is the light from these galaxies billions of years ago, to say that since then galaxies have accelerated to speeds greater than the speed of light. You can go further and say that there are more distant galaxies that we cannot see that are moving away even faster. So you may come to the conclusion that there are galaxies in the universe that are moving faster than light. But the redshift is not due to the Doppler effect, and this acceleration of the expanding universe does not does not actually cause a real increase in speed. We have to look for other solutions here. We already know that the universe is expanding from the Big Bang. Sometimes astronomers are by no means saying that the recession speed, the breaking of the universe, is greater than light, and that the expansion of the universe causes distant galaxies to move away from each other at just the right speed. But this is confusing, they admit. In general relativity, it is possible to actually increase the space between objects without increasing the relative velocities of this object accordingly. The universe is expanding. Let's do it again. How big is the universe? This will be the crux, the goal of my speech here. I would like to propose here that the size of the universe depends on the curvature of space-time in an expanding universe. You can see it spectacularly on the spherical curve of space-time. Space experiences an enlargement, time moves on. The size of the universe is not the same as the age of the universe. The age of the visible universe is estimated at 13.7 billion years light. But the real universe, if we were to measure the latter, would be 2,500 times larger than the visible one. Really, universe bigger than seen. Measuring is a wonderfully important, consistent element for flat planes. If the universe was flat, we would observe the universe smaller now. If the universe would undergo a sphere-shaped space-time and would be curved, we would have seen the universe bigger now. Here I would say that in our epoch, however, we see a larger universe. Let me repeat, this is the universe that we see now. Bigger, I ponder. If the space-time of the universe is saddle-shaped, we will see the universe as smaller for a long time to come. Here I will use an example with two bees, ants, that went on the way. If the ants walk on the flat plane that do not move away from each other, what is more, they are walking parallel, still at an equal distance from each other. If the ants walk on the sphere of the ball, we see them as if they are moving away from each other, but over time they may get closer again. If ants move saddle-shaped space-time, we could see them drift apart, and for good. It would take a miracle and some more time to see them again, and it would be a miracle of life, in my opinion. According to modern science, only if the universe is in the shape of the sphere, then it could be infinite and the phenomenon of life would repeat itself. And I come to such conclusions. Hence, we are launching more space probes to look at the visible universe, because we want the miracle, the phenomenon of life, to be able to repeat itself once again in the universe. According to Einstein, time is equal to matter, so we can think of space-time as in plot. The vertical arrow is time, the horizontal arrow is space. The Hubble constant describes the rate at which the universe expands as a function of time. A law was formulated, now called Hubble's law. The radial velocities of receding objects are proportional to the distance, r. H is the Hubble constant. This constant has an estimated value. You may see in my essay in internet. By no means common sense tells us that the optimal rate of expansion of the universe would be if they were moving diagonally across space-time. If we were going in the direction along the space line, the time function was close to zero. If we were going towards the time interval, then space would occupy a small scale. But how would it happen if there were more energy matter? How is the universe expanding? Background radiation is the type of electromagnetic radiation with thermal energy decomposition that is the black body spectrum with a temperature of 2.7 Kelvin. The maximum energy density falls on a wavelength of 1.1 meters. This radiation is a remnant of the early stages of the universe's evolution and the period of electron and proton recombination. Relic radiation hardly interacts with particles of matter and fills the universe almost uniformly. In the early evolutionary stages of the universe, matter and radiation quanta interacted in a state of thermodynamic equilibrium. The temperature of matter and radiation was very high, hence the universe at this stage is called hot. The knowledge of the temperature of the relic radiation makes it possible to estimate that the mass of primary matter consisted of 75% of hydrogen and 25% of helium. So then, right after the Big Bang, the temperature was high. On the map of this universe that is being drawn up, you can also see the cold island. I would now like to say that you cannot select one prominent direction in the universe. There is no privileged direction for the expansion of the universe. The theory of relativity proposed by Einstein described the universe relatively correctly. On the basis of the achievement of the theory of relativity, let us now ask how big is the universe. We see it over 92 billion light years, thus observing the universe 46 billion light years in all directions. And the universe already exists 13.7 billion light years, as I said. That is the age, so old. How is it possible? We clarify this first, based on our technology for measuring the size of the universe, and second, based on our now perspective of the universe we are observing. The universe is flat, so some people argue. Then all possibilities are acceptable, because it all depends on seeing observation and measurement. Common sense and intuition tell us that the universe would turn out to be infinite if we were only guided by the space-time curvature of the expanding universe. I believe so. Each of us dreams of an optimal universe. I see such a world as infinite with curved space-time on a sphere. Whether this dream could be realized, I am not able to say. I will not say that the next probes launched by humanity into space make this dream come true. By no means, however, in our era, we use speaking at the visible universe, see Webb probe, only to let mad humanity exist a little longer in an unfavorable reality. I believe, as I said in one of the previous statements, there are 4 possibilities for an optimal picture of the universe. Time final, infinite space. Final time, final space. Infinite time, infinite space. Infinite time, final space. Observing the universe at the beginning of the 3rd millennium of human civilization, we wish to see better the miraculous. See here curved universe. In the time warp of the universe, a new miracle may happen. For example, Jesus, the Son of God, may come back to this world to unite us definitively. definitively. Then our bodies will be resurrected and we will undergo a natural transformation of our little bodies, a transformation from spirit, as well as supernatural transformation, a transformation of our expanding bodies according to the plan of God the Father. What I wish for myself and for you, I am grateful for your patience and cooperation in leading this reflection from the heart to my listeners and readers, wishing you an abundance of God's favors.